on the track, on my face in the back like I'm taking a slap. I need a drink.
Hello everyone, welcome back to Eudomania. So as we have discussed our strategy in our last lecture, so today's lecture we will start the basic from the integration chapter. So the topic is integration. First we have to know what is the actual definition of integration. So integration is nothing but the inverse process of differentiation. It is the inverse process of integration. If you suppose the integration is I, then it is the inverse process of differentiation. Sometimes it is asked that you have to find the antiderivative. Antiderivative is the same meaning as the integration. So sometimes it is asked find the antiderivative instead of integration. So never confuse that. Now we have said the integration is the inverse process of differentiation. I hope you all know what is the differentiation. So like there is a function of x. There is a function of x. X is a variable and is a function of x. When we differentiate that function of x, we will get another function. And when we integrate that result function with respect to x, we will get the same function f of x. When we take an example, it will become more clear to you. So this portion is called integral of fx. This is the integral of fx with respect to x, and this is dx. This portion is dx is called differential of x. So whenever we will find the integration, it will always basically find with respect to some variables. So now like there is an example like f of x equal to x squared. So when we differentiate that x squared, you will get 2x, and when we integrate that 2x with respect to x, you will get x squared. So this is the basic terminology about the integration. Now there is a certain part like this integration. This is the symbol of integration. Integration of fx dx equal to, we get some another function. So in this case, the portion under the integration is called integrand, and what we will get after the implementation of the certain rule of the implementation, that is called integral. Means the function which is to be integrated is called the integrand, and the function whose dc is the integrand is called the integral, and the process of finding the integral is called the integration. So these are the some basic and the theory portion that we have done. Now there are some points. Whenever we will find the integration of any question, always we have to end with a constant term. Why we will add the constant term? Like as we have taken an example, f of x equal to x squared, and when we differentiate this x squared, we will get 2x, and when we integrate that 2x with respect to x, we will get the similar term x squared, but here we will have to find a constant. We will have to put a constant term at the end of the expression. Now why? Suppose there is a function of x. When we differentiate that, we will get f of x, and when we integrate that f of x with respect to dx, we will get f of x. This type of stuff we are studying right now. But suppose we are differentiating a function f of x plus c, constant term is also added with that function, then similarly we will get, because the differentiation of the constant term is 0, so it becomes 0, so we will get fx. And when we integrate that fx with respect to x, according to our theory, it becomes f of x. But in the differentiation term, we have a constant term. So here is the possibility that constant term in the given expression. So whenever we find the integration of any expression, we will always add a constant term at the end of the expression. So this is the very important point that you have always keep in mind. Now see the constant term. If there is a point that always keep in mind, if c changes, that integral of the function also changes, means integral of the function depend upon the c. So always keep in mind, integral of a function is not unique. This point has been done. Now there are two type of integration we have to study. First one is indefinite and second one is the definite integral. All the rules, principles are equivalent for both the type of integration, but only the difference is that in indefinite integral you don't have any limit over the integration chapter, but in definite integration you will have certain limit over there. So you have to apply that, and how you can apply that we will see in our upcoming videos. So only difference between the integration, definite integral and indefinite integral is that in indefinite integral you don't get any kind of the limit over there, but in definite integral you will have some limit that will help you to find the finite number of the answer. In indefinite integral the answer is infinite, means infinite number of answer you will get, but in definite integral you will get the finite number of answer. Now the basic concept has been done. Now we have to understand some basic results. So now we will see some important results or basic formula that will help you to solve all the questions, all the basic questions of integration. So let's get started. So if you get a constant term, if you get a term like this x to the power n dx, then what you will do, you will simply add 1 in the power divided by that constant term. Means if you are getting a value like this, integration of x to the power cube dx, simply what you will do, simply you have to add 1 in the power, means 3 plus 1, and the divide by the same number 3 plus 1 dx. So simply x to the power cube dx equal to x to the power 3 plus 1 divided by 3 plus 1. It becomes x to the power 4 divided by 4. First. Second, if you have nothing, means here is the 1. If 1 into dx you will get in the integrand, simply you will write x term, x plus c. Constant term always you have to write in indefinite integral. Now exponential term, if you will get a term like this e to the power x dx, simply you will have to write e to the power x plus c. But if you get a term like this, integration of e to the power 2x dx, then simply you have to write e to the power 2x, but this x multiply with the 2, so you have to divide that 2 term here. We will discuss it further in upcoming session. Now if you will get integration of 1 by x dx, so simply we can write log of x. Like simply if you get 1 by x dx, you can write log of x. If you will get integration of 1 by x plus 5 dx, you can write log x plus 5, because the coefficient of x is 1, and whatever question you have, if the coefficient of x is 1, you can simply write that. But if you are getting a term like this 1 by 2x plus 3 dx, you can't write directly log 2x plus 3 plus c. So you have to keep in mind, the when you apply this formula, the coefficient of variable x should be 1. Okay. Now next term, integration of a to the power x dx is becomes a to the power x log of x, means you are getting a term like this in integrand, means integration of 2 to the power x dx. Simply you can write for this term 2 to the power x, means whatever term here you have to write that term in numerator 2 to the power x divided by the log of x to the base e. So this is the question property result number 5. Now if you will get a term like this 1 by square root of x dx, you can simply write 2 to the power x plus c. Now some trigonometric basic formulas. If you get integration of sin x, it becomes minus of cos x. If you get cos x, you have to write sin x. It is the opposite, means in differentiation, when the start to find the differentiation of sin x, you will get cos x, and when you find the differentiation of cos x, you will get minus of sin x. The similar and the opposite thing here in integration. When you find the integration of sin x, you will get minus of cos x, and when you find the integration of cos x, you will find the positive of sin x. So this is the anti-parallel to each other. Now Integration of sec square x dx becomes 10x. Integration of sec x into 10x becomes sec x. Many portion you will get these two formulas. It will help you to solve many questions. Now, integration of cos x into cot x dx equal to minus of cos x plus c. Integration of cos square x dx becomes minus of cot x plus c. Now, integration of 1 by square root of 1 minus x square dx equal to sin inverse x. How? When we find the differentiation of sin inverse x, it becomes 1 by 1 minus x square root of dx. So, when we integrate that term, simply we will write this term, so sin inverse x. So, it becomes 1 integration of 1 by square root of 1 minus x square dx becomes sin inverse x. Now, integration of 1 by 1 plus x square dx becomes tan inverse x plus c, and integration of 1 by x into square root of x square minus 1 dx becomes sec square x. These two formulas, this and this, is very important. You will get many places where you have to apply these two formula to find the answer. Now, one more term, as we have mentioned while explaining exponential function, if you are getting a constant term with variable term, means like you have to find the, simply you have to find the integration of cos x, then you can write sin x. But when you got the integration of cos of 2x dx, you can't only write sin of 2x plus c, it will not the answer. You have to divide by that constant term having multiplication with x. So, this is the right answer. So, this note, it says that if ax plus b occur in the integrand in place of x, the result will obtain must be divided by the constant term a. Means whatever constant term is multiplied with the variable x, you have to divide that constant term to the given or result expression. So, these are the some basic results. You can pause the video and note it down, it will help you to solve many questions. Now, we are talking about properties of integration. There are two properties. If while finding the integration of a integrand, if there is a constant term, so we can write that constant term out from the integrand portion. So, here if the k into k is the constant term into fx dx of integration, then we can write the constant term out and the rest term will be the same. First property. Second property is that if there are more than two functions are associated with any operator, only for plus and minus operator, not the multiplication or division. If there are two functions are associated with plus or minus operator, we can simply separate these two functions by the given expression or operators. It is not only for the limited for the two functions, there are a certain number of functions. If they are associated with the plus or minus sign, then we can directly separate those functions. So, this is basically for the today lecture. In the next lecture, we will see some questions on these concepts. So, now I will see you in the next lecture, and thanks for watching.